Today our topic is exponents, our learning target. What are the exponent laws and how are they applied? Exponents. From our investigation, we should know that the product of powers property, meaning when we multiply powers, we add the exponent. So this would be a to the m plus n power. So we add the exponents. So multiplying powers means you add the exponents. So a numerical example of this would be 7 to the second power times 7 to the fifth power would equal 7 to the 2 plus fifth power, which would be 7 to the seventh power. We add the two exponents together and we get the answer. Power of a power property. So you're taking a power, raising it to another power. We multiply the exponent. So this would be a to the m times n power. So again, if you need a numerical example, if we had 7 to the second power raised to the fifth power, that would be 7 to the 2 times fifth power, which would equal 7 to the 10th power. So you can see how that is different from our first property when we're multiplying. So to write this out, power to a power is what we call that. You multiply your exponents. All right, and then lastly, the quotient of powers property. Quotient means you're dividing. So if we divide powers, we are subtracting the exponents. We would do a m to the m minus n power. So we're subtracting those powers. So if you need a numerical example, if we had 7 to the fifth power over 7 to the second power, we would do 7 to the 5 minus 2, which would be 7 to the third power. So when we are dividing powers, we subtract the exponents. Now remember, to apply these rules, they must have the same base. And remember, the base is the big number. So here in all my examples, I gave you the same base. It was always 7. Okay, if it doesn't have the same base, it doesn't work. So if we were trying to do 6 to the second power divided by 5 to the third power, we couldn't use these rules. It wouldn't work. Some additional rules would be our investigation plus the distributive property. So the distributive property works kind of the same way, where we distribute the exponent. So the exponent is going to be distributed to the two bases inside. So we would have a to the m power times b to the m power. So a numerical example of this would be if we had 7x to the second power, we could distribute the 2, that exponent, to both bases inside. So it would be 7 to the second power times x to the second power, which would actually be 49, because that's 7 squared, times x to the second power. All right, so it helps us to simplify things. And then the same thing for the power of a quotient property. We just take that exponent and give it to both bases. So this would be a to the m power over b to the m power. So if we needed a numerical example, if we had x over 3 taken to the second power, we could distribute that 2 to the x and to the 3. So it would be x to the second power over 3 to the second power, Well, we know that 3 to the second power is 9, so we could actually rewrite that as x to the second power over 9. Last piece is 0 and negative exponents. Anything taken to the 0 power is 1. So 7 to the 0 power is 1, 10 to the 0 power is 1, 1 million to the 0 power is 1. Anything taken to the 0 power is 1. A to the negative n power is actually 1 over a to the positive n. So if it has a negative exponent, to make it positive, we move it into the denominator, which I know can be kind of confusing. But if you look right here, here's a nice example of that. So a numerical example would be 3 to the negative second power. We know 3 to the positive second power is 9. But 3 to the negative second power is different. So this would actually be 1 over 3 to the positive second power. So when we have it negative, to make it positive, it goes in the denominator. So then this would really be 1 over 9. Because 3 squared is 9. Lastly, a to the positive n power is 1 over a to the negative n. So if we were given 1 over a to the, so let's change that to a number, 2 to the negative second power, we always want to have positive exponents. So since this is in the denominator, to make it positive, we move it to the numerator, which would then be 4. That one you won't see as often, but this one you really want to know. Okay? Lastly, just putting it all together, some examples. So for this one, we have a parenthesis with many bases taken to 1 power. So we distribute that power. So we have 5 to the second power times x to the second power times y to the second power. 5 to the second power is 25 times x to the second power times y to the second power. That's as much as we can simplify, so we leave it. Here we have 2 times x to the fourth power times 5 times x to the second power raised to the second power. Now here it's important to notice that this 2 is only going to this last set of parentheses. So we rewrite this as 2 times x to the fourth power. We give this 2 right here to the 5, so we'd have 5 to the second power times x to the second power raised to the second power. Now, we can do nothing with this parenthesis right now, so we just rewrite it. 5 squared is 25. And now here we have a power taken to a power, which means we multiply. All right, so 2 times 2 is 4, so this would be x to the fourth power. Lastly, we do our multiplication. Do like things. So 2 times 25 is 50. And then x to the fourth times x to the fourth. Here we're multiplying powers, which means we add the exponents. So 4 plus 4 equals 8. So 50x to the 8th power. So we just have to make sure we're keeping all of our rules straight. Lastly, we have some work with negatives. Here we have -6 in parentheses taken to the negative second power, which remember we just rewrite as 1 over the base taken to now a positive power. So it's really just changing that power to positive once you make it 1 over. So then we have 1 over -6 squared. That means -6 times -6. Negative times a negative is a positive. 6 times 6 is 36. So this is really 1 over 36. Lastly, we have -7 squared. Now, this we have to be careful of because there's no parentheses, which means the negative just comes down, and then we do 7 squared. which is 49. So this is negative 49, which is different from negative 7 in parentheses squared. Because then that actually means we're doing negative 7 times negative 7, which then would be a positive 49, because a negative times a negative is a positive. So we have to be really careful about how we evaluate with the negatives and exponents, because if the negative is here with no parentheses, then the answer is negative. But if there are parentheses, and like in this example, then our answer is positive. So just beware of those differences. Okay? That is all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.